I have a question here that I want us to share today. This question, I got it from a topic called area approximation. And it all depends on which method the examiner wants you to use in terms of getting the area. That literally is the shaded part of what I'm going to have here. And we have quite a good number of ways in which you can be able to get the area of a particular region on a Cartesian plane. It may either involve using what you call the differentiation or the integration. It may as well involve what you call the trapezoidal rule or the mid-ordinate rule. So today, I've been given here a graph, and this graph was drawn on the paper where I got this question. And of course, this is our y-axis and this is our x-axis. This is the shape of that graph. And we had a line moving downwards to this point and intersecting the x-axis at point 2. We had another vertical line dropping to the x-axis and meeting the x-axis at point 1. So this whole part has been shaded. So the examiner wants us to get the area of the shaded part of this curve. And the easiest way you can be able to do, you can actually decide to use a method called the integration method for you to get the area that is forming part of what has been shaded here. And the equation of the curve is a quadratic equation that reads y is equal to x squared minus 5. Y is equal to x squared minus 5. So the easiest way you can be able to actually do this question is just to first be able to have that sign of integration, and the limits that are able to mark the boundary of the region that is shaded are 2 and 1. And from this, the equation of that curve is given as x squared minus 5. So we are going to use the integration method for us to get the area that is under this curve, and more importantly, the region which is shaded. So how then do we integrate? We were told this in our last topic that is called calculus, that integrating means increasing the power to which x is raised by 1 and dividing the summation of that power just at the bottom where we have this letter called x. So we are going to have this as our final answer in terms of integrating that equation of that curve. We're going to have x squared, okay? Then we are going to increase the power to which x is raised to by 1 and get the summation of that new power. Then we divide all through by that power. So that means then we shall move to the next part of that equation, which is 5. So because there is no any variable on that constant given as 5 in that equation, we are going to introduce that constant, which is x. So we shall assume the x we have introduced is raised to 0. Then we can be able to say now the x raised to 0, which translates into 1 and confirms that there's no x which appears here, now can actually have a 1 getting added to it. Then the summation of that is 1. So divide all through by what? By 1. And of course, during integration, there must have been a constant which got eliminated when the equation got differentiated. And that translates into introducing that constant which was dropped or eliminated. So that our final integrated equation is going to be x cubic over 3 minus 5x raised to 1, then divide everything by 1 plus the constant, which is c. And this is a dy dx, or a derivative function, or a gradient function, you see, or an f prime, you see. So this is a derivative function, a gradient function, or a differentiated equation. So that for us to get back to what we had previously at the equation of the curve, we are going to have this getting integrated. We are going to have this getting integrated. So for us to proceed forward, we are going to have this. We are going to now say the limits given are 2 and 1. So that gives us x, okay, cubic, okay, over 3 and minus 5x, because 5x raised to 1 is the same as 5x. Then divide that by 1, it still gives you 5x. We shall say plus c. We can be able to use these brackets and be able to write the limits, which are 2 and 1. And to proceed, we shall be able to substitute where this variable x is with those two limits. So we shall have 2 cubic, okay, over 3 minus 5 into, okay, 2, close the brackets, plus the constant c. And we shall say this has to get subtracted, and we shall be able to subtract this from this other part that can actually take that other limit, which is 1. We will be able to have 1 cubic over 3 minus 5 into 1, close the brackets, plus the constant c. Okay, so then this lastly has to end up giving us which answer? So that is going to be 8 over 3, 8 over 3 minus 10, okay, plus c. Then proceeding forward, we shall have minus, okay, 1 over 3 minus 5 plus the constant c. So, of course, we are going to have 8 over 3 minus 10, that is the same as negative 7 and 1 over 3 plus the constant c. And this is going to be subtracted from, so is going to be plus c, then subtract this from, so a third minus 5, that is negative 2 and 2 over 3 plus the constant c. So minus 7 and 1 over 3, the constant is going to be eliminated. 1 plus c minus c is 0. So we shall be able to have minus 7 and 1 over 3 minus, that is plus 2 and 2 over 3. So that we will be able to actually get the difference between those two. Let me get my calculator. So we have negative 7 and 1 over 3 plus 2 and 2 over 3. That is minus 4 and 2 over 3. And in this topic, having gotten some assistance from another topic called calculus, you should be able to always tailor down to getting your answer without the negative sign. So you actually end up having your area as 4 and 2 over 3 square units. That becomes your final answer in terms of the area of the region which has been shaded under that curve.